All right, what we're going to look at in this video is we're going to just remind ourselves how do we find the equation to match an exponential table. The first thing I'm going to look at is to see how do my x values change. And every time they are consecutive values. So I know whatever my ratio is here in my y column, that's going to be my constant multiplier. So every single time I'm multiplying by 2, multiplying by 2. So I can see right away that my constant multiplier is 2. I also have given you here that your y-intercept is 8, so that means your starting value is going to be 8. So my equation to describe this table is y equals 8 times 2 to the x. But we also know we could just as easily pick this point here instead and say it's y equals 16 times 2. But this time I'm going to have to change my exponent because I'm sitting here at an x of 1. So I'd do to the x minus 1. This table here is a little bit different. What we've done this time is that we haven't given you what x is when it's 0. So we're going to not give you that starting value. But we can still go through the same process. We're just going to have to change that x, the value in our exponent. All right, here I can see again, they're all going up by 1 at a time. So I know whatever that ratio is going to be my constant multiplier, and I can see I'm dividing by a fourth. But it might be easier to think about this as multiplying by a fourth every time instead. Or you can think about it as dividing by a fourth if you like instead. So now what we can do is we can say that we have y equals, and we can pick any one of these values here. So I'm going to say y equals 120 times, and if I use 1/4, I have to put parentheses around it just for order of operations, and I'm going to raise it to the x. Now I want to get back to 0, so to go from -3 to 0, I need to add 3. If I wanted to go without the parentheses here, what I could also do is I could do y equals, I'm just going to take 30 instead, 30 times 0.25, and I can raise that to the x plus 2 power instead. All right. This one here, we are not giving you a starting value, and we're not giving you a constant multiplier right away. So here I can see that I'm increasing by 2 each time, and I can see over here that I'm multiplying by 9. So because I have 2 jumps in this 9, I need to find my constant multiplier by doing the square root of 9. If I wanted to use a graphing calculator, I can do that with the math notation, but I can also use 9 and then the caret to the 1/2 power on my home screen also. So I'd find in any of those cases that my constant multiplier is 3. So now I can say an equation would be y equals 63 times 3 to the x minus 4, because again I'm asking myself how do I get back to 0? Or I could pick the other one of the other points instead of y equals 7 times 3 to the x minus 2. This last situation we want to look at, because now we no longer have a starting value and we no longer have our values in order in the x column, and we can't just take the square root of something because there's more than just 2 jumps. So let's take from here to here. From 5 to 8, I know I'm taking 3 jumps. To go from -1/3 to -1/81, I'm multiplying by 1/27. Or you can think about it as dividing by 27 if that's easier. So because there are 3 jumps over here, I'm going to have to ask myself what times itself 3 times is going to give me 1/27. So I need to find the cube root of 1/27. Again, you can use your calculator if you want, or you can think about it as being the same thing as 1/3. So now I have y equals -729 times 1/3 to the x plus 2 power. Sorry, that really should be an exponent to the right of it. And then, or I could say y equals -1/3 times 1/3 to the x minus 5 power.